Hello grade 12s, Maths paper 2, Trigonometry. Let's look at this general solution question. 8 sin theta cos theta is equal to -2 square root of 3. The challenge that we have is that we have a mixture of sine and cos, but luckily we have a way of resolving that. We have a trig identity that says sine 2a is equal to 2 sine a cos a. So this is a double. This is a single of an angle. That means my task is to deal with the left hand side so that it involves a double angle. Luckily, 8 can be broken down into 4 multiplied by 2. Then I have sin theta cos theta is equal to -2 square root of 3. 4 times 2 is still 8, so it's present as it is. I haven't changed the value of the equation, but the advantage of making this breakdown is that 2 sine a cos a, I have an answer to it. So I expect also 2 sine theta cos theta to reduce to something like that on the left there. So I'm going to maintain 4, but this one will now be equal to sine 2 theta using that identity, which is also given on your formula sheet. Sine 2 theta is equal to -2 root 3. Now it's a bit simpler because I am involving only sine. Cos is no longer present. Dividing both sides by 4, sine 2 theta shall be equal to -2 root 3 over 4, which is equal to -root 3 over 2. Okay, then this negative, we will ignore it when we find the reference angle. Let's go through that process. Reference angle shall be sine inverse of root 3 over 2, ignoring the negative. And this gives me 60 degrees. That's the reference angle. Then I am now going to consider the negative that I have. Let's choose the appropriate quadrants in which the theta must lie, the 2 theta must lie. Okay, so cast says that here cos is positive, here sine is positive, here tan is positive, but this negative would suggest that I am in quadrant number 3 or quadrant number 4. But in quadrant number 3, angles are given as 180 plus theta. Here 180 minus theta, here theta itself 360 degrees minus theta. So I am in this quadrant. Therefore, I am going to take my 2 theta now. 2 theta is equal to, I add 60 degrees to 180. That gives me 240 degrees plus 360 degree k, where k is an element of set. This is how we deal with the general solution. We attach a multiple of 360 there to cater for revolutions that will come into that quadrant each time. Or then we go to the quadrant number 4. 2 theta shall be 360 minus 60 will be 300. The reference angle is subtracted in place of theta there. So it's 300 plus 360 degree k, where k is an element of set. Then what is left now is to divide throughout by 2 in both equations. In the first equation, I'm going to have theta is equal to 120 degrees plus 180 degrees k. Or in the second equation, dividing by 2 by 2 by 2, we'll get theta is equal to 150 degrees plus 180 degrees k. These are my 2 solutions, where k is an element of set, of course. But I've already introduced that because you don't have to do that every time. Once you introduce your k as being a member of set, you may not do it again. It's still fine. This is how we deal with the general solution of that type. Thank you so much.